All right. Stage 2 of subtraction algorithms. So the point of playing with the base 10 blocks is to warm the kids up for if there's not enough ones to take away, what do we do about it? So the example we looked at a moment ago was 32 minus 24. And we had to do a trade because there weren't enough ones. Okay. So normally for what I'm going to call the standard algorithm, what we do is what we do borrowing. And another phrase for borrowing that you'll see in the books a lot in the worksheets you're going to have with kids when you're teaching in the future, it's also going to be called the renaming algorithm. And we were working on this back in section 1. So I'm going to rewrite my 32 and stack it with the 24 so place values line up, right? I have my 1s lined up, I have my 10s lined up. And then I want to take 4 away from 2, but I can't do that. There's not enough to take away. And so that's where the borrowing, and I'll explain why it's renaming also. So what we do is we borrow from that 3, it's really a 30, we're now making it 20, and we're taking 10 and throwing it over here, okay? And so what I did in the renaming part is I renamed 3 10s and 2 1s as 2 10s and 12 ones, right? So that is what I mean by renaming. So you're not, it's not often going to be called borrowing anymore. It's often called renaming. And then we can say, oh, can I take 4 from 12? And the answer is, yeah, I can do that. That's going to give me, what, 8 on a good day? And then 2 minus 2 is 0. I'm not even going to write that down, but we could. But there's my answer, 8. And this borrowing, this renaming is the trading that we did with base 10 blocks. So we do that physical trading in to try and justify why we can get away with this renaming or borrowing. That 3 10s and 2 1s is the same as 2 10s and 12 1s. It's both 2 ways of saying 32, but one is easier to take 24 from. So this is again called the standard algorithm. It's called the borrowing algorithm. It's called the renaming algorithm. And remember, algorithm just means process, right? I don't really explain it, I just do it. I'm explaining it to you because you want to be teachers and we get to explain this to kids, but mainly we just want them to do it. Right? If we can get them to do it, awesome. That's the main goal. So some other algorithms. I'm going to show you my favorite for 32 minus 24. This one is called the equal additions algorithm. And here is the way it works. So let's see, I would like to do 2 minus 4, but I can't take 4 from 2. It'd be nice if that were a 12, because then I could subtract. Well, if I put a 1 there to make that 12, I just added 10 to the top number. So I'm going to add 10 to the bottom number. So I'm going to make that 20 or 30. 12 minus 4 is 8. 3 minus 3 is 0. Boom, I'm done. Equal additions. We'll try that again. So again, what happened here is that 1 at the top is adding a 10. And over here on the bottom, I also added 10, but in a different way. New example. So we're going to compare the standard with the equal additions algorithm. Let's try 312 minus 176. So if you could write that down and do the standard algorithm on it on paper. Oops. Standard is also called the renaming algorithm. So let's see, I can't do 6 take away 2, so I have to borrow, right? And that makes that a 12. Take away 6 is 6. That's easy. 0 take away 7. Darn, I can't do that. Borrow, that makes that a 10. Take away 7 is 3. 2 take away 1 is 1. So I got 136 if all went well. So I'm going to try this next with the equal additions. So give this a shot with me. So I write my 312 minus 176, and I'll use colors and stages on this one. Let's start with red. So I'd like to take 6 from 2, 2 minus 6, I can't do it. So it'd be nicer if that were a 12. So I change this 70 into an 80 to compensate. 12 take away 6 is 6, no problem. New color. 1 minus 8, oh man, I can't do that. So I'll make that an 11, and that was a 10, so now it's 110 there. So I'm gonna add 100 over here by making that 1 a 2. So let's see, 11 take away 8 is 3, and 3 take away 2 is 1, and there's my answer, 136. Same answer. Equal additions. So what happens here, I'll just make a note about if you didn't catch on to what was going on there. If you can't subtract, right, which happens sometimes, because you don't have enough in the bottom or the top, right, we make the top number a 10, right? We add 10. Add 10 to top digit. To compensate for that, we also add a 1 to the bottom digit in the next column. Okay, so I'll just repeat these rules for that same problem. 3, 1, 2, 312, take away 176. I can't do 6 minus 2, so I add 10 to the top number, and in the next column, I add 1 to the bottom number. And basically what I'm doing is I'm adding 10 to the top and the bottom in special ways. 12 minus 6 is 6. Now that's really a 10, that 1 is a 10 and that 8 is an 80. I can't do that subtraction, so I put a 1 there, which instead of 10 is now 110. And to compensate, adding that 100 up there, I add 100 over here by making that 100 a 200. Okay. Digit-wise, I made this digit 10 more, and I made this digit in the next column at the bottom 1 more. To compensate for the place value, 11 minus 8 is 3, and this one's pretty easy, 3 minus 2 is 1. Okay. So these are the rules right here for the equal additions algorithm. I find the equal additions algorithm is most useful when you have a bunch of zeros in the top. So let's look at one more example of this and we'll try a different algorithm. Let's suppose we had 2021 next year minus, let's say 17. Actually, no, let's do a little different. Let's put more zeros there. Let's do 2006 minus 1777. Now, the problem with the standard algorithm on this one right here is there's nothing to borrow from here, and so you have to work your way across, and this freaks a lot of kids out. Right? So with the standard algorithm, I say, okay, I can't do 6 minus 7, so I want to borrow. I can't borrow, can't borrow. Finally, over here, I can borrow. So I take 1 away from there, make that a 10. Take 1 away from there, make it a 9, make that a 10. Take 1 away from there, make that a 9, make that a 16. Oh my gosh, right? That was a lot of work. Alternative with the equal additions is it's just not quite as much reaching across and back. So if I apply the equal additions algorithm here, I just go one column at a time. 6, oops, something went wrong. Oh, that was supposed to be sorry about that, a 7 at the end there. I can't do 7 minus 6, so I put a 10 here and I bump this up to an 8. And then I can just say, okay, 16 minus 7, that is a 9. And then I move over to the next column. I don't have to worry about reaching all the way across. 0 minus 8, nope, can't do it. So I make that a 10 and bump that up to an 8. 10 minus 8 is 2. 0 minus 8 I can't do, so I make that a 10, bump that up to a 2. 10 minus 8 is 2. 2 minus 2 is 0, so I'm done. And if we completed this one over here, 16 minus 7 is 9. 9 minus 7 is 2. 9 minus 7 is 2. 1 minus 1 is 0. But I had all that heavy lifting to do up front, which is hard for a lot of kids. So this is an alternate way if kids are struggling reaching across a bunch of zeros to do a subtraction. Why does it work? Why does this work? I'm going to save that for another day, but it works. It's kind of cool. All right, a couple more algorithms. Let's see. New page. Let's try. Ooh, yes, the Hindu method. Remember we did the backwards addition the other day? There's a backwards subtraction. So we're going to do the Hindu algorithm. And there's one of these in the homework. It's sometimes called the left to right algorithm. And let's take one of those previous examples that we already know the answer to, like 312 minus 176. All right, so we'll do this a few times, try and get the hang of it. So we start on the left side and we subtract over. So first thing I do is I think about, okay, what's 300, right? So this is first on this side. 300 minus 100 is 200, no big deal. But then over here, I'm trying to do 10 minus 70, which doesn't work. So we borrow from below. So what I do is from that 2, I take a 1, bring it up there. So now it's 11 minus 7, which gives me what, 4. And then I move over to the next column. 2 minus 6, can't do it, so I borrow from below. 12 minus 6 is 6, and so there's my answer, 136. So that's the Hindu or left to right algorithm. This one is in the book as the left to right algorithm. The equal additions is kind of sort of in the book. They do it a little bit different. So let's try that again. Let's do the 2000, what was it, 2006 minus 1777. And we'll do the left to right version. So we start over on this side, and 2 minus 1 is 1. And I can't work 0 minus 7, so I borrow from over here up to there. And that's a 0, by the way. 10 minus 7 is 3. And then I come over to the next column. 0 minus 7, I can't do it, so I have to borrow from below, bring it up. 10 minus 7 is 3. Move over. 6 minus 7, I can't do it, so I borrow again from below. And then 16 minus 7 is 9, and so there's that 229 we had earlier. So it's nice. You don't have to worry about borrowing all the way across like you do with the standard algorithm. So all these algorithms have their pros and their cons. Different parts of the world use different algorithms. So that renaming algorithm is popular in the United States. The Hindu algorithm is popular in other countries that read left to right, and countries that don't read left to right. There's a few that do this. The equal additions algorithm is taught in some other countries also. All right, so I'm going to show you one more. New page right there. This one is called the complement algorithm. And it's the use of an easy subtraction and an addition to get other subtraction problems done. So complement. So a complement is a number that works together with another number. Oops, my tablet is low on power. Hopefully it makes it through class. Uh, so let's see, complement. Let's take one of the previous numbers, 312. Oops. Oops. Sorry, my tablet running out of power is freaking me out. 312, what is the complement of 312 with 1000? So a complement is something that fits with something else. It's not complement, like with an I, right? Like my, you look good today. Complement in this case means the other, that makes a whole. And we talked about complements a little bit with sets. The complement of a set is everything outside of that set. So the complement of 312 is what do I need to get from 312 to 1000, right? So another way to ask that is what's 1000 minus 312? And the way our number system works with nines is if the first two numbers, like that's going to be an 8, add up to 10, then that's going to bump everything up for a 9. So I asked myself, okay, what plus 2 is 10? 8. Then after that, because the 10 is going to carry, I asked basically what do I get? 1 plus what is 9? Well, that would be an 8. 3 plus what is 9? That would be a 6. And if you double check that, what is 688 plus 312? The 8 plus the 2 gives me a 10. That 1 jumping over takes that 8 and 1, which was a 9, plus 1 makes that a 10. 6 and 3 was a 9, but now it has an extra 1 on the top, so it's a 10. So there's an easy way to subtract out of something like 1,000 or 100 or 10,000. And the trick is what you want to do in the first one is make 10. And then for each of the other places, you want to think, what do I have to do to make a 9? And it's a quick way to subtract out of 1,000 or really any power of 10, 1,000, 100, 10, 10,000, a million. So we'll try this again in just a moment, but I'm going to show how to use the complement method to do a subtraction. So let's see, we had 312 and 176. So down here, we'll actually do it. 312 minus 176. All right, so, oops, I think I just did this backwards. Hang on, let me wrap my mind around this. I did. I want to do the complement of 176. That's okay. Give us practice. What is 1,000 minus 176? And usually I just think it. I don't write it down. So with the first digit, I want to make a 10. Then after that, I want to make a 9. So 824 would be the complement of 176 for 1,000. 1,000 minus 176. So back over here, I look at the bottom number, and from the 6, I say, okay, what do I need to make a 10? I would need a 4. And then what do I need to make 7 into a 9? That would be a 2. And what do I need to make 1 into a 9? That would be an 8. Then I add the two top numbers together. 4 plus 2 is 6. 2 plus 1 is 3. 8 plus 3 is 11. But then I just get rid of that extra 1,000 right there, and what's left is my answer. Seems kind of like a magic trick, but it's not. So what's the point of this? The point is finding a complement of a number is often easier than doing a regular subtraction. And once I do that, I can just add two numbers to get the difference. But then we get rid of the extra 1,000, the 1,000 being the 1,000 from the complement. So we'll try this with another pair of numbers. So let's get a new pair. So first, use the standard algorithm on, let's say, 423, and we'll take away from that 275. So use the standard algorithm to get the answer so we can check to see if the complement method works for us because it's new. Okay, so I got 148 if I didn't make a mistake. Anyone else get that? Let's see, I can't see you guys, so I need someone to give me a yes or no.
Yes.
Thank you. Okay, so now let's try the complement method. So we're going to do, again, leave a little space above, 423, take away 275. I'm going to switch colors for emphasis. So to find, we want to find the complement of the bottom number out of whatever the next place value was. So since these are hundreds, I'm thinking about 1,000. So to do that, we make a 10 and then some 9s, the way our borrowing and carrying works. So 5 plus 5 is 10. 7 plus 2 is 9, and 2 plus 7 is 9. So this number above is the complement of 275. Then I add the two top numbers together. So 5 plus 3 is 8, 2 plus 2 is 4, 7 plus 4 is 11, but we get rid of the extra 1,000 there. And there's our answer, 148. And that's called the complement method of subtracting.
Can you explain that one more time when you were like 5 seconds ago?
Making a complement?
Yeah.
Mm-hmm. So the trick on making a complement, so let me come down below, to make a complement. Complement is always the next highest place value. So I started with 275. And so the trick is for the ones column, we want to make a 10. So what would I add to 5 to make 10? I would add a 5. And then for the other two places, or however many places there are, you're trying to make a 9. So what would you add to 7 to make a 9? We would add a 2. What would we have to add to 2 to make a 9? We would add a 7. So 725 is the complement of 275.
Okay. All right, thank you.
Yep. And we always start with the bottom number. Okay. Okay. So let's see, what else do we need to do here? We went over a few algorithms. Let's see, where did I put my notes? Over here. We went over a few different models. We are just about done. Let's see if there was any tricky problems in the homework that I didn't talk about. And then, oh, we got to talk about the activity. Yes, perfect. Come on, Zoom. Please show me yourself. Zoom, hello. I'm stuck in share screen mode. Maybe if I stop sharing. Uh-oh, that's not working either. Can anyone still hear me? Are you guys out there?
Yes, I can.
Yeah, I can hear you.
Okay, and you still see my screen. Why won't you let me stop sharing? Oh, there it goes. Whew. All right, let's stop the recording.